Well, very good morning. I apologize for my voice. I've got a problem, so I may start coughing in the middle of my presentation. So our paper is titled Externalization and Ownership of Cybersecurity for Smart Buildings. Right. Now, the paper is about cybersecurity for buildings, which is in buildings, smart buildings, really, is an area of industrial controls, building automation systems, building management systems. The terminology varies, but they are very much interchangeable. And we see that it's an area that is not very clear in terms of how to implement cybersecurity. Then again, and there's reasons for that go beyond technology. So the study we do is, right, considering the circumstances of managing a building or facilities, who should own cybersecurity within the team? That is essentially our key problem. I'll start with an example. In 2013, Target in the US was hacked. It was a major breach, and the way it started was that's what is told. So I cannot confirm, and nobody really can confirm. But what is told is that it got started by a contractor, an HVAC contractor. HVAC is air conditioning, heating, and that kind of functionality inside the building. So what seems to have happened was the targets was connecting the two networks, the buildings one, the normal IT payments customers systems, and that was a major mistake. So what happened was criminals compromised the industrial controls network, hopped onto the payment system, and then exfiltrate the data from there. So this is just an example of how serious things are, including a new concept that we haven't seen it very often. Good thing, but it's called siegeware, which is essentially holding a building to ransom. And so it's pretty much ransomware, but instead of blocking files or a computer, they lock the building. So a building management system, they're not new. They've been around for quite a few decades. Even a 30-year-old building will have very interesting automation. BACnet is a common protocol. You find BACnet, Modbus, which is very common across all industrial controls. BACnet in particular is building automation control network. It was created in the 90s, and you see buildings having, whenever you see little boxes, and inside the boxes there will be essentially two wires, there will be a BACnet terminal. And that BACnet, that protocol, will control things like heating, automation, air conditioning, energy, rooms. Very much, it's a very versatile protocol. However, security is virtually non-existent, and the reason why security is very difficult to embed in BACnet, it's not because there's no extensions to BACnet, but because, and this is the drama of industrial controls or security for industrial controls, the infrastructure already exists. Changing one device implies changing the whole building, and this is just very complicated to do, to the point that existing no incentives to do this, and that's also part of the problem. Well, buildings will just stay as they are. Buildings are also part of the critical national infrastructure, which is defined at the government level. In the UK and in Europe, they're not directly part of CNI. However, they support CNI. For example, hospitals, the network of hospitals is part of the critical national infrastructure, and obviously hospitals depend on building automation. So Technically, they are critical national infrastructure, so security, network regulation, for example, NIS in Europe and the UK. So the Network and Information Systems Directive, they don't apply directly to buildings, but then they will apply indirectly to buildings. So it is a very, very important sector in the whole of society. This is an example, very, very generic, of how buildings are actually automated, and you don't need a very, very sophisticated building to have this kind of networks and this kind of architecture inside. You've got all sorts of subsystems on the bottom. That's the plant of the building, HVAC, car parking, security, and CCTV. I am so sorry. I am so sorry. So you've got the infrastructure, car parking, services, security and CCTV, access control, vertical transportation, that's lifts or escalators, occupant well-being, say CO2 monitoring, for example, lighting, water and energy, fire control. All these devices are connected using some sort of protocol. BACnet, Modbus are very, very, very common. They connect to a layer where there's communications on network and networking, and then you see upper layer services that go from simple aggregation of values, display of values, for example, for an operator, all the way to added value services, reporting, more on the side of strategy and management. This is very, very common. Even an old building, a 40-year-old building, so done in the 80s, 1980s, they will have, to a certain sense, to a certain extent, this architecture. It's very, very common to see at least one computer, usually very, very old, running Windows XP or Windows 95. This is still very, very common in a small room somewhere that nobody cares about, but it is a major liability in terms of cybersecurity. So we've got cybersecurity is still very, very immature for buildings, despite this being 2022. There is many reasons for this. There's perhaps 4 groups of reasons. One, we do have insecure systems and protocols. The example that I gave of a computer, very, very old computer, running Windows 98 and effectively controlling the whole building or allowing visualization of the whole building. It is true. It is here in Birmingham. I visited the building and it was the case. And then BACnet, Modbus, they're very, very difficult to secure, not because there's no extensions, security extensions. The problem is updating the devices to run it. Again, there's no incentives. It's very, very difficult. You need to rip off the whole infrastructure, the wires and so on of the building, and nobody really wants to do that. There's also immature convergence between OT and IT. OT in the sense of operational technologies, IT information technologies, as we are used to hear. Building automation is part of OT. Whereas it makes sense, of course, to have some convergence between OT and IT, using the same protocols, same servers, same technologies. It just creates more trouble in terms of security than creates solutions. Because it's very fast, very pressing, this convergence, but security is still lagging. It's still legacy devices that, for example, then again, BACnet is insecure, and the way this convergence is happening is simply converting, adapting the values from BACnet into some database, something more friendly to modern IT. But then again, the actual automation is still run over BACnet, the insecure BACnet. 2 other reasons is inadequate business models. We'll see this. That's very much the center of our paper. And then lack of specific standards. I'm part of a group here in the UK of the Internet of Things Security Foundation, the working group about security for smart buildings. And And it is one brave attempt to bring a cybersecurity standard or best practice into the professional environment. There is virtually no standards, no best practices, no guidance for smart buildings. This is difficult to understand, but it is the fact. So if we take a look more closely to inadequate business models, we see that in particular it is unclear the ownership of of cybersecurity. So what we did in our paper was run a stakeholders analysis. For buildings, it makes much more sense because, say, if it's let's say a nuclear power plant, there's usually one owner. The owner runs all the power plants. He runs the team. So there's a delegation of authority in the whole nuclear power plant. For the situation is completely different. You've got many parties that come into play at different times in the projects, in the project plan, and then the ownership of cybersecurity gets lost. It truly gets lost. Nobody knows. Nobody is actually running the cybersecurity. So what we did was, let's run a stakeholders analysis, and let's create what is known in project management, the RACI matrices. RACI in the sense of who is responsible, who is accountable, who is consulted, and who is informed about, in this case, cybersecurity. The responsible party is the whoever actually carries out the task. Accountable is whoever is ultimately accountable for the quality of the outcome. Consulted are the parties who are asked for their opinion and their advice, and informed parties that should know the progress of the task. Now we run this and the matrices. We got the help of 2 construction businesses, 2 facility managers, and academics in the built environment, notably from the construction management side and the facilities management side. This is the stakeholders of a building, and as you see, it's not obvious, it's not clear who actually runs the building. You got the builder that at some point is not an active part of the scenario. They build the building and then hand it over, and then perhaps there's a maintenance contract, but that's their role stops there. You do have the owner. Someone must own the building. However, the owner of the building typically does not run the building. They're very often a bank. Who actually runs the building is the facilities management manager, the FM. What happens is the owner delegates to a facilities management company to run the building. The facilities manager then has subcontractors. One very important is the BMS manager, the building management system manager, who relies on integrators, who then on its turn gets devices and subsystems into the building. Then you've got the supply chain. That's a normal thing. It's difficult to map in terms of relationships into the existing parties. And then you've got the occupier, the tenants, people that actually use the building, typically renting an office or flats or some space inside the building. But on a day-to-day basis, it's the facilities manager that runs the building. Of course, the facilities manager basically keeps the owner happy, keeps the building running, efficient, with good maintenance, etc., but will not take the initiative to do anything more than that. And that's where cybersecurity, the problem starts. So who from these parties should actually own and drive and have the incentives to own cybersecurity for the building? And this is problematic. There's nobody here that should do that. Maybe the owner, but the owner is maybe a bank. So they don't care. They basically, it's not their business. It's not their core business. It's not something they are interested in. They put in the capital. They expect revenue from the capital. That's it. The FM very likely is probably the best positioned party to do that. The occupier definitely not. They don't have access to the whole building. They simply renting a fraction of the space. So this is very complicated. So when apologies. So when you list all the parties involved in running a building and map them against the responsible, accountable, consulted, informed roles, you see that it's very unclear. Consulted, yeah, nearly everybody should be consulted. Informed depends on the relationship of custody of running the building. The question is who is responsible and who is accountable. In particular, who is responsible for running cybersecurity, and it's not clear at all. The integrator, for example, may be partially responsible for cybersecurity, but it's within a small subsystem. For example, if there's computers running Windows, well, then the integrator should be responsible for getting the updates from the device system vendor, Microsoft in the case, applying the patches, and then its function stops there. They cannot be, say, updating a lift, for example, because it's not their responsibility. So it's very, very difficult. It's all very disintegrated. When you look at cybersecurity domains, because cybersecurity in terms of a program is fairly complex, so nobody does the same thing really. Everybody specializes in a certain aspect of cybersecurity, and then keeping in mind that this is industrial controls, so it's not normal information assurance cybersecurity. But we listed a couple of a few domains in cybersecurity. We simply took inspiration from the NIST cybersecurity framework, a very well-known framework for security. GRC, which is governance, risk and compliance, risk management, secure systems, very important for industrial controls, people and training, asset management, access control, third-party management, monitoring and detection, incident response and continuity, digital forensics, and communications. Right. And now let's look again at the parties, the roles, the stakeholders we've identified, and who is responsible, accountable, consulted, and informed. Then again, it's not clear. Lots of people consulted, lots of people informed, a few people accountable. However, there is one clear pattern, which is the facilities manager seems to be in the best position to be responsible for cybersecurity. When you map along the cybersecurity components of a program, it's not surprising, but this should be taken with a grain of salt, in the sense of it is, of all the parties, it's the party better position to do that. It doesn't mean they have a natural vocation to do that, and that is the problem. So our conclusions are then it's unclear who owns cybersecurity for building, and this is probably what is say dragging the field and the insecurity of buildings. Again, buildings are still flying a bit under the radar. You don't hear many incidents, but they will appear sooner or later, also because buildings are very much associated with the public space, so it's very difficult to enforce physical access control doors. Very much, anybody can pick a lawyer. A door is just, if you're interested, you can look at the videos of the pick locker lawyer, something like this. It's very, very interesting, and you see how doors are very, very, very insecure, very difficult to trust, really. So on the other hand, this is a nascent area. So in terms of research, so this paper is the beginning of a research strand. So we need indeed integration between the different subsystems that the BMS consists of, and the constant evolution and merging between paradigms such as legacy BMSs, internet-based technologies, IoT, and the cloud. So all this combination makes the problem of security for buildings very, very complex. It's well beyond, say, encryption or systems or integration. It's well beyond that. It's truly a socio-technical system, and security needs to cover all these angles. We need frameworks and frameworks that need to be adapted and perhaps expanded and aligned with the professional practices in the built environment, and not the other way around. So one problem, even though there are a couple of, say, approaches to cybersecurity for buildings. There's in the paper there's a mention of this British standards that actually expired. Interesting, but the cybersecurity approach and the framework and any best practices, any guidance that comes from it, must be in consultation with the professionals acting in the field. Otherwise, it'll be very, very difficult to implement and deploy, simply because who will do that if you don't negotiate, if you don't dialogue with the stakeholders? Well, thank you very much. That was my presentation. I'm open for questions. Thank you.